Hi, welcome to my channel. In this video, I will present my recent project I have done with my previous company, Pharma Intelligence. So I have divided the project into four step of system design principle. Let's start with the step one, understanding the problem and defining the scope. So what was the business goal? So researchers in the pharmaceutical industries needs a timely access to high quality research data for their scientific publication and drug development activities. And our pharma intelligence platforms automate the data collection, processing, and distribution, providing researchers with a centralized and AI enriched research experience. So our goal is to provide research data to the researcher of the pharmaceutical industry. So we have uh, tie up with a n number of providers that provides research data to the InfoDesk company, and then we ingest that data into our database, and that we provide that data to the researcher in the form of article. User will have an account in our platform. User will log in and create a connection, and after creating a connection that the particular user wants the data of like PubMed, and then he creates a connection, and we will ingest the data from the relevant provider, and after a few seconds, a user or researcher will get the article related to that particular domain he subscribed for that. And let's talk about the core features. So features we talk about, we have provider in integration, like we have some in sub providers like PubMed, FDA. So they provides the data to our ingestion service. We will ingest it and save it to our database to serve to our researcher. And we have a subscription model also, and real-time data ingestion service we have also created. Article search, we have also created article search feature. AI summarization feature we have also created. So if there is a long research article, so researcher don't need to spend a lot of time to read entire article. So we have added the AI summarization feature to provide the summary of that particular long research article. Also, we have created a RAG based AI assistant system to query whatever the researchers need in the real time from our private pharma research database. Key requirements are: system should be highly scalable and secure and highly available even if the high amount of load on a particular time, and some should be tenancy and near real-time data delivery. And what are the constraints? So different providers API. So there are n number of providers. They provide different endpoint. We have to manage their endpoint, and there are some like authentication mechanism. For the authentication for each API, we have to manage all those things and verifying the data format. So each data providers will provide a data into different format, but we have to format we have to get that data and format that data into a specific format to serve into our pipeline, and then save into our pharma research database. Also we have to think about healthcare compliances, large data volume, because there are n number of providers and n number of researchers who are requesting a data from our portal. So there is highest possibility of large data volume, so we have to take care of this thing. Let's talk about the estimating scale and the identify bottleneck in the second step. So if we talk about the scale, millions of research articles are there. So we have to manage the scalability. How, like, if we have like millions of articles are there, how we can manage thousands of customer we will have, thousands of connections can a researcher can create, and thousands and millions of data can be available into our database or into our connection, easy to readable and easy to manage, and should all the articles should be responsive, and we have multiple provider integration also. So let's talk about the traffic. So continuous integration jobs, like we have n number of providers, n number of jobs are there, so we have to manage it efficiently. Some AI queries, we have to manage AI queries efficiently. Article searches, so search should be like efficient, and customer portal access should also be a major criteria to be focused on for the traffic. And potential bottleneck, provide the API rate limit and database performance, message queue throughput, AI model latency, and vector search operation. So we have to think about the API rate limit and database performance, message queue throughput, and AI model latency, and vector search operation. So this may be a bottleneck when we scale our system. Let's talk about the capacity planning. Distributed customer. We have a distributed customers scale database. So if like load will get increase on a particular database, so we have to scale the database. We have to use like Kubernetes auto scaling feature, and also we can use service bus topic partitioning to manage the heavy data into a service bus. And the third step, high level design, services, API, and the communication. So core services like there is a provider service, ingestion service, provider service. In the provider service, there are a number of providers we are connecting and we are getting the data, and there is ingestion service who that gets the data, and there is airflow orchestration, like a number of providers we have created a cron job, so airflow will orchestrate all those jobs. And service bus, like when we push the data to the service bus, consumer will consume the data. And consumer service also we have to create AI processing services. We also create like summarization service, AI summarization feature. We have to create AI processing service like AI intelligence assistant chat system. We have to manage the AI processing service. And API gateway we have to use for sending all the client request and forward that request to a specific service, for like API gateway for rate limiting and authentication, routing. We can use the API gateway. And React front end, we have to use as a front end React. And data flow, like provider will provide the data, ingestion server will ingest, and airflow will orchestrate all those jobs and will send the data to the service bus, and then consumer will consume the data from the service bus and save the data into the database, and customer portal will use that data for their research articles and serve the data to the researchers. AI layer, also we think about a article summarization, RAG-based chat assistant using embeddings and vector search. So this AI layer will be helpful for AI communication. And for the communication, REST APIs for user operation and asynchronous messages by Azure Service Bus for data processing. For like provider and consumer data accessing, we can use for Azure Service Bus. So Azure Service Bus is a pub sub service model. And last is the step 4, making tech and infra decision strategically. So in this, we have chosen the Python microservices for ingestion, the large amount of data format to the specific format, and React as a front end, Azure SQL to store our database, MongoDB for like highly scalability to manage all those connection or all those articles, Azure Service Bus to manage the pub sub subscriber, like event driven architecture. We have used Azure Service Bus for providing and consuming the data. Airflow we have used for cron job orchestration, OpenAI for AI summarization, Kubernetes for the deployment orchestration of the container, and for the scalability we have used horizontal scaling, consumer group, database sharding. We have used read replica and write replica, auto scaling cluster we have to use. And for the reliability and the security, retry mechanism should be implemented, and dead letter queue should be implemented when the data has come to the service bus and consumer is down for some reason. Then after like consumer will get up, and then we have to pull again the data from the dead letter queue. So this kind of thing we have to manage. For the authentication or to Azure ready RBAC, we have to also integrate into our system. TLS encryption is also important for secure communication between the services, and Azure keyword to store our secure keys in a Azure keyword. For the observability and DevOps application insight for user analytics and tracking the system errors, and centralized logging to check the log for applications, and if there is any problem, or we have to ultimately go to that log and check. And health check also, we have to check that service health check, if we have to check that if any service is healthy or not. CI/CD pipeline we have to configure efficiently and automate the deployment. So last final summary of this requirement is that we have a multi-provider data sources like PubMed, FDA will provide data to our data ingestion service. So we have used Apache Airflow for data ingestion. Like we have created cron job for each data provider, so every day it runs and then get the data and data in through the data ingestion Python service. We get the data and we format the data into a specific format, and then we send the data to the Azure Service Bus message queue. And there is a consumer who subscribed for the particular topic in the service bus, and they consume the data and then save that data into the Azure SQL, MongoDB, and VectorDB, and structured and unstructured data. VectorDB structured and unstructured data we have to take care to save separately either in SQL or MongoDB. VectorDB for AI related thing. AI summarization plus like RAG assistant system we have developed. Like we have to take care of the OpenAI API usage, embedding, how to save the embedding in VectorDB. So we have to take care of those things. And finally, React portal. So we are serving to the n number of researchers to get their article for their research. APIM for managing the APIs, user interface and API gateway. We have to take care of it. Finally, we are providing a service to the pharma researchers. So guys, thank you for watching this video.